Hey everyone, this is Coach White. Today I'm going to be showing you Unit 0, Day 4, which is transformation. Some of you may remember this, but this formula right here we kind of use for a lot of different things and a lot of different functions. So we're going to be learning how to graph several types of functions throughout the year, which we already did, so this is kind of a review. And all of them will follow this pattern. By the way, this is like function notation. So anytime you see like f of something, this just means the function, okay? And this works for any function, whether it's linear, whether it's quadratic, whether it's absolute value, any of them work, okay? So the first thing that we're going to be talking about is this plus or minus right here, okay? If there is a negative in front, that means it is going to reflect over the x-axis, okay? Or in other words, it's going to flip down, okay? Sometimes we call this like a roxa, reflect over x-axis. So if we were to see this, okay, so let me pull up little Desmos on the side over here. If we were to see this, look, oh, my bad. If we were to see this, okay, so we would have y is equal to, I'm going to put negative f of x. See, we see that it flips down, okay? So it's just going to cause it to flip, okay? Now we're going to come over and we're going to see that our a value right here. Okay, so now we're going to be talking about the a value. If the a is going to be in between 0 and 1, so in this case, a fraction, okay? If it is a fraction, it is going to become wider, okay, or it's going to flatten. Now, the other thing that we need to keep in mind is if our a value is bigger than 1, okay, that means that is going to get skinnier, or it's going to stretch, okay? Either of them are fine. So I'm going to go ahead, I'm going to pull up Desmos again, pull it to the side. I'm going to change this, and watch, I'm going to put a fraction. You see how it got wider? Okay, so if it's a fraction, okay, it is going to be wider. Now, please, if there's like a negative in front over here, don't take that into consideration. Like this is something on its own. Just look at this value, okay? So the 1/2 means it's going to be wider, okay? I'm going to look at this one. Do you see how it's a 3's in front? Okay, that is greater than 1, so it's going to get skinnier, okay? Or also a stretch. Okay, we're going to be looking at this part in the parentheses. This part right here has to do with x values, okay? If we have x minus h, okay, that means it is going to go right, however many units h is, okay? So if this was like x minus 3, that means it's going right 3, okay? So we call that our crazy x. Then if it's like 8x plus h, wild guess, that's going to go left, okay? So if it's x plus 1, it is going to go left 1, okay? So this right here, if you want to make a note, this is the crazy x, okay? And if we want to see that, we can look that up on Desmos, okay? And I'm just going to change this one. I'm going to do minus 3. See how it went to the right 3? Like the vertex right here went right 3. That's what I'm looking at. Now if I do plus 3, it's going to go to the left. See, the vertex went left 3. Okay. Last but not least, my very favorite one is the k value. It does exactly what it says. Okay. So plus k means it's going to go up k. Meaning if I had plus 4, it's going to go up 4. Okay. And then if it's minus k, it's going to go down k. Okay. So again, it's exactly as it looks. This one's going to go up. And this one's going to go down. So if I had minus 2, it's going to go down 2. And again, all different functions follow this rule. And function, again, is like the type of graph. So quadratic, linear, absolute value, cubic, things like that, okay? So looking at our transformations here, let's do the very first one. I'm just going to visually show us some of these so you can see it, okay? We're going to do the very first one. Well, this one right here, I'm looking at the a value. Okay, and our a value is, it's greater than 1. So it looks like, on our graph, perfect. This is going to be a stretch. And that's all you got to put. Okay, let's go ahead and look at this one. It looks like we're going to have 2. Here's our crazy x. Okay, so it looks like it's going to go right 4. And we have this one right here, which is going to be up 8. Let's look. Good. Look. Okay, see? It went to the right 4 and up 8. Perfect. Okay, let's go to the next one. How many do we got here? Good, it looks like we have 2. So we have this negative. So we have a roxa, reflect over x-axis, or a flip. And then this one right here with our crazy x, it looks like it's going to be left 1. Let's look. Good. Flip and a roxa. Okay? By the way, if you are ever doing graphs, you need to flip first. Okay, just every time flip first. Okay, here's another one. We kind of already did this one. So this value right here, my a value right here, is in between 0 and 1. This also means it's a fraction. Okay, less than 1. If you had a fraction like this, okay, that's greater than 1, so that would actually be a stretch. So please make sure that it's in between 0 and 1. So this is telling me, let's look, it's getting wider, so wider, okay, or flattened. Okay, it's getting squished, essentially, okay? So that is just with our transformations right there. So if a teacher asks you, what is a transformation? It just means how it's moving, okay? So this one had 1 transformation, this had 2, this had 2, this had 1, okay? Now, when we're doing this, like graph the transformations from the given parent function by building a transformation table, okay? This is broken into parts. You see there's like different parts of this graph. Like a quadratic is real fluid. It looks like this. A linear looks like this. It's very fluid. Absolute value is very fluid. Well, this is like in pieces. So that means we're going to have to do things in pieces. So first thing I want to do is name the transformations. Okay, so one is transformations. And it looks like we only have 1. And that is going to be up 2. So I'm going to take every single point and move it up 2. Okay, so there's 1, 2, 3. Connect the lines. Good. So that right there would be f of x plus 2. Let's go to the next one. Looks like we got 1 over here. And it looks like this one is going to go right 3. So I'm going to go 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, 3. Perfect. So we're just moving the dots. Okay, so this one the first one translated up, the second one translated to the right. Okay, now we got 2. Okay, so there's our 2. So it looks like we're going to go right 2 and then up 3. Okay, so 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3. Done. See, easy money, not too bad. Okay. Now, when we do this right here, okay, this is like being multiplied by 3. So this is going to like stretch by 3. So that means we need to go ahead and make a table for this one. This is called a transformation table. I'll make it a little bit different colors so you can see. Okay, here's x and y. And then these ones over here are going to be like the transformations. Okay, there is nothing happening in here. So that means all our x values are going to stay the same. Okay, so let's go ahead and let's do those first. We have 1, 2, 3, 4. So we have negative 4. Okay, so I'm doing this point right here. This point is 1, 2, 3, 4, negative 4, comma 1. So that goes here. Okay, so I did that point. Now let's do the next point, which is right here. Negative 2, negative 2. And then the last point looks like it's going to be 0, negative 2. Okay? Now, again, with our transformation, nothing is happening to the x. Okay? So that means all our x values are going to stay the same. Okay? Now here, this is getting stretched by 3. So that means all my y values, I need to multiply by 3. That is where this came from. Okay? We are multiplying by 3. So I'm going to take all my y values right here and multiply them by 3. So 3 times 1 would be 3. We have negative 2. Oops, sorry, y'all, my bad. Okay, and then we're going to have negative 2 times 3, which is negative 6. And then 0, negative 2s, we're also going to have negative 6 here. Okay, Multiplying, what we're doing is we're just taking this times 3, this times 3, this times 3. Now, this right here is my new points. Okay, so I'm going to have negative 4, comma 3, or negative 4, 3. Okay. Negative 2, negative 6. Ooh, it like comes right off the page. 0, 1, 2. There we go. That would be our graph right there, so we stretched it, okay? Those ones are a little confusing, so that's why you have to make like a transformation table with it, because you're just taking all the y values and you are multiplying them by 3, okay? Let's go ahead and do E. So with E, this is very similar, okay? This is almost the exact same as our table over here. So I'm just going to take this whole table right here. I'm going to copy it, and I'm going to put it over here. Let me shrink it a little bit, okay? But obviously, our values are going to be a little bit different, so I'm going to get rid of all these, okay? But as you notice, the values for our x and y are going to be the same. Now what we're doing is this right here. Again, nothing is happening to the x's. There is nothing on the inside of the parentheses, so all these are going to stay the same, okay? But now it's going to be 1/2 y. I am multiplying all my values by 1/2 because anything that happens on the outside of the f of x is going to deal with y. If there was something on the inside, you would put it with the x values, okay? I can show you another table like that too, okay? So I'm actually going to pull up my calculator just to make sure. So I'm going to take all of these and I'm going to multiply them by 1/2. Okay, so this would be 0.5, this would be -1, and this would be -1. I actually didn't really need the calculator for that. Okay, so we're going to do -4 and then 0.5, which is right there. And then -2, -1, and then 0, -1. Bam. Okay, so it just got a little bit wider. Okay, it's a little more slanty. Okay. Now this next one, we only have one transformation happening here. And that transformation is the flip or the Roxa. Okay. So I'm going to take all my values and I'm going to flip them over the x-axis. Okay, so this is 1 away, so that means the other one's going to be right here. Okay, this distance needs to be the same. So this one has 2, so that means the other one's going to be 2. And then lastly, this one's also 2 away, so the other one's going to be 2 away. So right here. I'm going to erase these lines. And there would be our line. It reflected over the x-axis. That's the only thing that happened, okay? Now, for a transformation table, y'all, I just want to show you what this transformation table would look like. Okay, I'm going to move our transformations up here. Okay, so again, all the x and y values have been the same. So we have -4, -2, 0, 1, -2, -2. Okay, now this is how we would do our transformation table here. I'm going to look at this. The transformation we said was right 2, so that means it's going to be x plus 2. Okay, now this goes up 3, and that is a y value. Okay, so it's going to be y plus 3. Okay, anything that happens on the inside is going to have to do with x, and then this is going to deal with y. You go off the transformations. It said right 2, so I'm going to go x plus 2. So let's go ahead and check our work. Okay, so -4 plus 2 is -2, 0, 2, and then we're adding 3 to all of these. Okay, let's check. Do our points match? -2, 4, -2, 4, good. 0, 1, and 2, 1. Perfect. It works. Okay, so this whole thing right here is called a transformation table. And sometimes you need to use them and sometimes you don't. Usually if there's like a stretch or a compression, that is when you're going to have to use it the most. Okay. All right, let's go on to the next section right here. So again, some of these we are going to have to use a transformation table, but some of us do not. Okay. So this one right here. Okay, so we have a reflection. And then we have down 3. Okay, so I'm going to reflect it first. So if I reflect it, it's right there. Okay, you always reflect first. Okay, so I'm going to reflect it, and then I'm going to go down 3. 1, 2, 3. Okay, I'm going to reflect it and then down 3. Okay, this one right here, if I were to reflect it, it would go here first. Okay, and then I would go down 3. Okay, so reflect it, now down 3. 1, 2, 3. If I were to reflect this one, it would be right here. Okay, so I'm going to start here and go down 3. 1, 2, 3. And then I just mimic the shape. Good. Okay, always reflect first. Do not forget that. Okay. What I would like you to do is, especially for this next one right here, I want you to pause the video and I would like you to try this on your own. Okay, your graph should look like this. And I did a transformation table just because I wanted you to see an example, but that would be your answer for this one. Sorry, y'all, my bad. Okay, let's go ahead and let's go to this one. Okay, so it looks like, man, all the values are the same, so I'm going to get rid of this. It looks like in this case that we are only going to have one transformation. Okay, so I went ahead and did C. So here's all our x and y values. So x, this is -4, 1, -1, 1, 0, -1, and 1, 1. There is nothing inside, so all the x values are going to stay the same. Now we have a stretch by a scale factor of 2, so we're just going to multiply all the y values by 2, which is where this came from. Here are my new points. Okay, so I have -4, 2, -1, 2, 0, -2, and 1, 2. So this right here would be my new line. So we see that there was a stretch happening right here, which is exactly what we want. Okay. Let's go ahead and let's do this next one right here. Again, I'm going to copy this whole table and I'm going to put it over here because all the values are going to be the same, more or less, except for the y's. Okay. And I notice that is because, look, here's our stretch. Actually, this is not a stretch. This is going to, we can also say it's like compressing. So this is actually going to get wider, okay, or compressed. Either way is fine, okay? And the scale factor is going to be this 1/2 right here. So I need to multiply all these y values by 1/2. So it looks like we're going to have a lot of fractions, okay? So we're going to have 0.5, 0.5, -0.5, and 0.5 again. Okay, so I'm going to go over to -4 1/2, -1 1/2, 0 1/2, and 1 1/2. So look, it looks like our whole thing was squished or compressed. Okay, that is why I like the transformation tables, because you can see everything that happens. Okay. Okay, this one right here, we have a lot of different things happening, okay? So I'm going to make a transformation table for this one. I would like you to do the same too. Okay, so let's do our x and our y values here. So I'm going to go from left to right. That's how I'm going to label them, okay? So the first one we have is -5, 2. The second one is -3, 0. This one is 1, 2, or -1, 2. The next one is 1, -2. Hopefully I'm getting these correct. And then I have 3, -2. Okay, so we have a lot of different points we're working with. Let's go one by one. Okay, I'm going to highlight all the things that happen to the y values. Okay, so I'm going to have 3y. Okay, and then let's do the next one. Okay, so now I'm going to have x plus 2 because this transformation is right 2. And then this one is going to be up 4, and this is a stretch. Okay, so up 4, I'm going to put plus 4. So notice how this is a little bit different than the rest. We have two things going on now. Okay, so now's the time. If you need to get your calculator, please do so. But we're going to write all our values here. So all of these, I just need to add 2 to our x values, okay? So -5 plus 2 would be -3. And then we have -1. And then we have 1, 3, and 5, okay? Now this, I'm going to plug in y for every value. I'm not going to do this for every one, but I would, like for this one, I'd do 3 times 2 plus 4. And the next one would be 3 times 0 plus 4. So just for the sake of showing all the work, I'm going to put this here. You do not need to do this. This is just also for me to check my work at the same time. Okay? So we're going to get all our y values here. Okay, and again, I'm just taking this and plugging it into here. Okay, so I'm going to go ahead and I'm going to do all of these on my calculator just to triple check because, you know, teachers make mistakes too. This is going to be 10. This one's going to be 4, 6. This is also going to be 10. Then we're going to have 3 times negative 2 plus 4. Negatives can be tricky, so negative 2, and these are the exact same. Okay, so this is telling, these are my points right here. Negative 3, 10. Negative 1, 4. 1, 10. 3, negative 2, 5, negative 2. So let's go ahead and let's plot those. So I need to find negative 3 and 10, which is going to be way up here. Then I'm going to have negative 1, 4, which is right here. Okay, and the first line is going to be like this. Okay. And then, so I did this one, I did this one. I need 1, comma 10, which again is going to be like way up here. So I'm going to connect that. And then I'm going to have 3, negative 2. Jeez. Okay, 3, negative 2, which is way down here. And I'm going to have 5, negative 2. Good. There's our new function. Okay. Again, transformation tables are nice because you're going to have to plug everything in. Okay. And for those of you who are curious, again, this is my point right here. Negative 3, 10, negative 1, 4, 1, 10, 3, negative 2, 5, and negative 2. Okay. All right. This right here, this is just some algebraic review. The first thing that you have to do is this. Okay, that is very first. We need to solve for x. So 2x minus 1 is equal to 13. Add 1 to both sides. 2x is equal to 14. Divide by 2. X is 7. Now this is the second part right here. Then what is x plus 3? Okay, second part. 7 plus 3. 10. So 10 would be your answer. Okay, just a little bit of algebra review. All right, next one. Again, I know it's going a little bit fast, but it's called review for a reason. Okay, this is what we're doing first. So 1/2 x plus 7 is equal to negative 3. Subtract 7 from both sides. 1/2 x is equal to negative 10. I'm going to multiply both sides by the reciprocal. Okay, so then x would be equal to negative 20. Another way that you could check is you could plug this back in. So what's half of negative 20? Okay, negative 10. Plus 7, negative 3, so it works. Okay, let's do the second half. So this is the first step. And let's do the second step. So 5 times negative 20 minus 4. If we plug that into our calculator, you can also do some mental math, but we just want to triple check. This right here would be, see, I even plugged it in wrong. Okay, so this right here would be negative 104. Okay, so just do it in pieces. That would be the biggest thing that I'd say. Not too terribly hard for those. Okay, we're going to do these. It says 2 lines given by the equation above intersect in the xy plane. What is the value of the y-coordinate at the point of intersection? Okay, I don't know if you guys remember this, but this is huge. If we see this, we're going to use substitution. Okay, another way that you could think about this problem, by the way, is like 3 heart minus 2y is equal to 15, and the heart is equal to 3. A lot of you have seen this in like games when you were in middle school where it's like solve for the heart. Okay, that means the same thing, so I'm going to plug it in. Okay, so this is what we're going to do. We're going to do 3. We said the heart, or in this case, the x was 3. Minus 2y is equal to 15. Okay, so this would be 9 minus 2y is equal to 15. Minus 9 from both sides, so negative 2y is equal to, we have our 15 minus 9, which is 6. Divide both sides by negative 2. So y would be equal to negative 3. Okay, it says what is the value of the y-coordinate? So that's all we need to do. If it were to ask for the x value, you would just plug it back into here, but we're given the x value right here, so we don't need to worry about it. Okay, and the other way that you could see this when you're practicing. You could also do this on a calculator as well. You could come into here and you could put, you'd have to solve this for y right here, but we could do 3x minus 2y is equal to 15. And then we could put x equals 3. And then we see the y coordinate of intersection is -3. Okay, so that's a good way to check. Okay, this says this function g is defined by g of x equals 3x plus 8. What is the value of g of 12? Okay, this is important. We usually say g of x, right? So therefore, when we say g of 12, this means right here that x is equal to 12. That is what that is saying. So when I come to my function right here, all I'm going to do is put g of x, or you actually, more professional, you'd put g of 12, because that's what I'm plugging in for x, is 3 times 12 plus 8. And if you plug that into your calculator, 3 times 12 plus 8 is going to give me 60. So you would say this, g of 12 is equal to 60. Okay. The biggest thing is knowing this. Okay, make sure you know that. Write the equation of the line that passes through the point 0, 0. Okay, right here. Passes through the point 0, 0 and is perpendicular to the line shown. Okay, so the first thing that you need to do is find the equation of this line. I'm going to zoom in, okay? So this is a line, so y equals mx plus b, right? Okay, so our b value is the y-intercept, which is 3. Okay, now we need to figure out what our slope is. So let's go ahead and let's find that. Okay, so I'm just going to do this because there were the 2 points given. So I went down 4 and right 5. So my slope is going to be -4 over 5. Okay, so this is the original line. Y is equal to -4 over 5 x plus 3. Okay, this is this problem over here. Okay. Now we need to make sure that it goes through the point 0, 0. Okay. And it is perpendicular. Okay. Perpendicular means that it is going to meet at a 90-degree angle. Okay. So 2. If a line is perpendicular, the original slope, okay, the original slope is -4 over 5. If it is perpendicular, okay, this is a good thing to remember. If it is perpendicular, that means it is going to the opposite and flipped sign. So the reciprocal and the flipped sign. So now it's positive. If it were to be parallel, it would have the same slope. Okay, so if it was parallel, it would have the same slope. So it's going to be 5 over 4, and it is going to go through 0, 0. If it goes through 0, 0 right here, that means that is going to be the y-intercept. Okay, so when writing my equation, y is equal to, we said it would be 5 over 4x, and it needs to go through 0, 0. That would be our y-intercept. That would be your equation. Do I need plus 0? No. So this would be okay. And we can also graph that too if we really wanted to, but that would be your line that is perpendicular. And if we want to check, okay, let's go over to Desmos again. Okay, let's do the first one we had. We had y is equal to -4 divided by 5. X plus 3. And then our next one is y is equal to 5 divided by 4 over x. Perfect. It goes through 0, 0, and they are perpendicular. Makes a 90-degree angle. Okay. So those is good for all our notes right there. Now, when you guys do this, again, it says build a transformation table. Please make sure you do that. I will help you get set up for the first one. I would always make column like this. Here's the first one with your original x and y, and then your transformed x and y are going to go into these ones. I would make the table on every one. Okay, now the ones that have like the +2, the right 3, those I don't think you need to make transformation tables, but the ones with a stretch or compression, you need to make them. Or the ones that have multiple stuff going on like this, you need to make a transformation table, okay? These ones should be not too bad. You just have to plug in the values, okay? Perfect, okay? So these are the ones that you need to do today. But make sure you look back on this, use your transformation tables, and make sure you understand this.